Hello everyone, welcome to my channel. So in today's video we are going to talk about how can we perform load shedding in a Spring Boot embedded Tomcat, right? So before we dive into what is load shedding and how do we do it, there are few properties of Tomcat that I would like to discuss with you. So as you can see on the screen, so these are some of the important configurations. The first one is server Tomcat threads max. So this is the maximum amount of worker threads and its default value is 200. What are worker threads, right? For example, so you have a service running on a Spring Boot application which is on embedded Tomcat, right? And there are a couple of RESTful endpoints for it. Now when you post a request, what Tomcat does is there are various connectors like blocking IO and non-blocking IO. In our case, let's assume that it's a non-blocking IO connector, and then when you submit a request, it gets handed off to a worker thread. The worker thread is the one which actually performs your request. So if there are the default number of worker threads is 200. So what this means is that your Tomcat can at a given time it can perform 200 requests in parallel. That is the maximum number of requests that it can serve in parallel. And this is the default number, and you can always change it in your configuration. The next thing is the maximum connections. So these are the maximum number of connections that the server accepts and processes at a time, right? So in a non-blocking IO, with a non-blocking IO connector, a single thread can serve multiple connections. So when some of the connections are waiting on IO, the threads can switch over and then they work on the other connections. But in blocking IO mode, each and every connection will get its own thread. So that means if you have threads limit set to 200, that means there can only be a maximum of 200 connections coming into your system. Whereas in case of non-blocking IO, as you can see, the default is 8192. It depends on the connector again, that number, but as you can see, this number is way higher than the threads, the number of threads. So that is because each thread can serve some more number of connections. And the last thing is the accept count. So what this means is that if, for example, if all of your threads are busy, that means if there are 200 requests and all your 200 worker threads are busy, and there are requests coming in non-stop to your system, and you have hit your max connections, right? That means the server has reached your limit of, let's say, 8,000 connections. After that, there is a queue where the connections can come in, and that queue size is 100. That is the accept count. So once it goes above the accept count, it depends. Like maybe sometimes it can reject it saying the service is not available with a 503 error, or it can wait till the connection times out, either from the client side or from the server side. I hope these properties make sense, but I can try to explain it once again as we look into the next topics, right? So now let's see an example here on how we can or let's see an example of how would this worker threads come into play and what is load shedding all about, right? So let us say we have two services, right? One is called service A and the other one is service B. Okay, now service B is dependent on service A. Okay, this is dependent, right? Sorry, the way I'm writing it is not so clear, but basically service B is dependent on service A. And now let's say that as we discussed, the max thread property, right? There is a max thread property here, right? Let's say this value is set to 3. Max threads value is set to 3 for the service A. So what this means is that service A can serve a maximum of 3 requests in parallel. It cannot go beyond that. Now, for whatever reason, let's assume that service A has become really slow. Maybe there is another system that this depends on called service C, and the requests coming into A are dependent on C, and because of that, the service A has become really slow, right? When that happens, now service B sends a request to service A. Let's call this the first request, right? Now one of the thread takes up this request. Another request comes in. The second Tomcat worker thread takes up that request. Another request comes in. Third request, right? Now another Tomcat thread takes up that request. Now we've reached our max threads of 3, right? Now at this point, your Tomcat can no longer take new requests. Basically, it cannot process new requests, but it can still accept new connections. And it can accept connections up to the default, which is 8192, right? Like we saw in the slides. So that means Tomcat can still accept connections, but these connections, they are waiting, right? Because they cannot be processed, because there are only 3 threads, worker threads, and all of them are busy. So all these connections that are coming from service B to service A, they're waiting for it to be processed. So at this point, what would happen is, usually when you send a request, example a HTTP request for another service, you would put something called a connection timeout, right? So there's something called connection timeout, right? So what if you put this as 10 seconds, so what this means is that service B would wait for 10 seconds to connect to service A. So now what this means is that if there are thousands of, maybe hundreds or thousands of requests coming from service B to service A, and if all of the service A threads are busy, now all the other connections going out from B to A, they will be waiting until this connection timeout is, it waits for like 10 seconds and then it maybe establishes a new connection, right? So what the effect of this is, service A B has become really slow now, because each and every request coming in is waiting for 10 seconds because it is dependent on service A. Now what would happen is, this would spike up the latency. Like if there is a P95 or P99 for service B, all those values are really spiked up. Now if there are other dependent services on service B, right, each and every one of them would be impacted if they're directly dependent on service B. So this is a cascading failure, right? Because if there are dependent systems, each and every one of them is impacted. Now, so this can really happen in production. Like if you have several microservices which are dependent on one another, and if they're not really, if the design is not async basically, and then if they're synchronously dependent on one another, if one of the services is slow, the rest of the services would be impacted in this fashion. So now this is the problem, right? So now what is the solution for it? Like if there is one microservice which has become really slow, and if there are other services which are dependent on it, which are affected, what can we do, right? Now let's go back to the slide. There are few solutions for it. First thing is circuit breaker, right? So what is circuit breaker? Basically, what you would do is, on the client side, in this case, let's call service B as the client for service A. On the client side, what you would do is, you would implement this circuit breaker pattern. So what this means is that service B will always keep track of the number of requests going out to service A and see the failure rate, like how many are timing out, or maybe how many of them are getting back a 503 error or something like that, right? So once, if service B, if the number of such timeouts or errors that reach a certain threshold, it opens the circuit. So basically what that means is that once a circuit becomes open, any new requests coming in from B to A, they'd be rejected immediately. They will not go to the service A. So this can actually help in two ways. One, you're not increasing the load on service A further, like you're not trying to throttle it. B, the second advantage is that service B itself is protecting from increasing its P95 or P99, because since you're now rejecting the request from reaching out to service A, you're protecting your own service from it. I mean, of course, functionality is broken, but it is restricted. The blast radius is restricted, right? And then after a certain time, service B again, it opens, like it goes into a half open state, and then it sends few requests to service A and sees, are the requests now succeeding? Is service A better? And if the requests are succeeding, then it would close the circuit and all the requests would flow into service A. If the requests are still failing, it goes back to the open state again, and then none of the requests would flow from B to A. So this is the circuit breaker pattern, right? I'll probably, in my next video, I'll talk in detail about this circuit breaker approach. The other solution is auto scaling, right? So what's auto scaling here? Like, so what we saw was that circuit A, the service A, it has hit its max threads, right? And then it's really choking here. So what we can do is maybe we can come up with some sort of metrics which are monitoring the Tomcat worker threads, or some other metrics, and then we can start scaling service A. Maybe there is only one EC2 instance of service A, so you can add one more instance in the load balancer, right? You can keep adding this, but again, at some point you would hit a limit, right? It's not an infinite scaling that you can keep adding these service A EC2 instances. You would hit a limit. But basically this is again another solution. When your service is under load because of some heavy traffic, you can start scaling your service and see if that helps. The last one, and which is what we are going to discuss today, is load shedding, right? So what is load shedding here? If you go back to the diagram here, so circuit breaker is on service B, auto scaling is on service A. Now what is load shedding, right? So now, for example, if service A, as we said, the max threads is 3, right? So what we can do is, once it hits the max threads, service A can start doing load shedding. So this is the first thread, okay, successful, but it is waiting. 2, successful, but it is waiting. 3 is successful. Now once after it hits this max limit of 3, any new request coming into service A, it will throw a 503 error immediately, saying this is not available, service is not available. It's fail fast basically. So how this helps is that any new connections coming in, they're not going to wait, right? They're not going to wait for till the connection times out. So this would protect the dependent services on the service A. So if there is a service B which is waiting on A, so now the service B gets a 503 immediately. It won't wait for 10 seconds or 20 seconds and then it fails. It fails immediately. So this is basically load shedding by service A. The advantage here is that you're reducing the blast radius, right? Like if there is an issue with service A, you just So only service A is affected when you start doing load shedding, because whatever the REST API or whatever features are provided by service A, they no longer work. But that's it. Service B does not slow down because service A has slowed down, like we have seen few minutes back. Or none of the dependent services on A would be slowed down. They'll start receiving 5 or 3 errors. That's a different issue, but at least they won't be slowed down because of service A. So this is how load shedding works, right? Now let's see how we can implement this in Spring Boot. Okay. Now I already have a simple controller here called employee controller. All right. It really does not do anything. If you hit this endpoint, it just says hello. Okay. And now if we go to our application YAML file, these are the properties that I discussed earlier. So we are listening to the server on 8888. It can be 8080. I just changed it. And these are the properties that we discussed, right? The max threads, just for the purpose of this video or tutorial, I've changed this to 4 max threads. These values we can leave them at default. We don't have to really tweak them right now. The accept count or max connections or connection timeout, we can leave them at default. We don't have to change any of them. So what you're saying here is, you're saying that this Tomcat server can serve a maximum of 4 requests in parallel. It cannot do beyond that, right? Now in a happy scenario, let's run this application, right? So once you start your Spring Boot application, and then once your controller is up, now if you go to a terminal here and then let's say hit this endpoint, right? So you're getting a hello response immediately, right? Which is good. Now let's assume that this Spring Boot application is your service A, and this curl calls using curl whichever request that you are sending to service A. Let us assume that this is service B. Okay, this curl endpoints or the request that you're hitting, let's assume that it is service B. Now in order to induce this slowness in service A, what we'll do is we'll try to put some thread.sleep here. So now what this means is that any request that is coming in, it would get stuck because thread is sleeping here. It won't respond back when a client submits a request. Now let's assume that there is no load shedding. I've already written up the code here for load shedding, but let's not activate it for now. Instead, let's start the application again, right? So now you remember the max threads what we have is 4, right? So without load shedding, the behavior would be you send a request, see, but you're not getting a response because the request is we put a thread.sleep here, so it's not coming back. So now you send another request, still waiting. This is your third one, and this is your fourth one. So all these 4 requests have gotten, but any other requests that go in after this, right? Connection would be established because, as I said, it would still accept connections up to a limit of max connections. So connection is established, but Tomcat is not serving this request. How do we test this, right? So before we proceed further with the testing, let me explain how we can achieve load shedding here. So it's pretty simple actually. So you write a load shedding class which implements filter. This is nothing but your simple so this is just your Java X servlet filter, and you implement this do filter method here, and then you have an atomic integer which checks on the request count, that is how many requests that your Tomcat is actively working on, and then you define your max request as 5 here. Basically we can give it as 4 maybe. So what this means is that if the servlet request is of type HTTP servlet request, and if your request count is greater than 4, what you want to do is you want to throw back a 503 error here. As you can see, I'm returning back a 503, which is service unavailable, right? If you've hit the limit, you return back a service unavailable to the clients. This means the clients who try to connect after the threads, the max worker threads are busy, they'll immediately get a 503 error instead of the waiting which we saw a few minutes back. But if the max limit is not reached yet, what you can do is you can just increment the request. Basically this is an indication saying that one of your worker threads is busy, and now you just do a filter chain or do filter. So what this does is it would send your request to your employee controller class. So first it hits the filter and then it goes to your employee controller class, right? That's all to it. So if you've hit the maximum request, reject anything that comes after. If you haven't reached your max request, then keep going ahead, like increment your request count and then call do filter. Once application employee controller is done with its processing, and when you have to return your response, right, just before you return the response, it would come here in the finally block. You're reducing the count again, and then you're so now let's start the application with load shedding in place and see what happens. So we have our max requests set to 4, and then in your load shedding as well, so if it is greater than or equal to 4, you want to reject your request, or let's give this 5, and then in here if it goes above 4, that means you want to reject your request, right? Now let's start the application. Now go to your local terminal 1 is your first request, which is we set a wait of here of 500 seconds, so it is waiting in this controller class now. You fire your second request, which is again waiting. How you can say it is waiting? So you can see the thread count is going up, so and then it's not finishing it and reducing it. Now let's fire your third request, 3 and 4. Now all your 4 threads are busy, as you can see here, 1 2 3 4. Now let's see what will happen to the 5th one, right? So now you're firing your 5th one. See, it immediately failed with a 503 error saying sorry, I'm busy, try again. This is because this is coming from your load shedding filter here. In here it hit the load shedding threshold of 4 requests. Now the 5th request that comes in, it is rejecting it immediately. So this is what I tried to explain in the document that if you see here, like if there are after 3 requests, any other requests that come into service A, they should fail with the 503 error. That is exactly what we are seeing here. It is failing. Let's fire another one, 503. So as you can see, there's no wait time on, if you consider the terminal as your service B, there is no connection timeout. That the connections are not waiting on service A to process. Rather, service A is immediately rejecting, saying, hey, I cannot process anymore, and then it's giving back a 503. So now this protects service B from waiting on service A, and indirectly its P95 or its latency won't go up. Basically it would receive a bunch of 503 errors, but that's all to it. So let's go in detail here, right? What we are doing here. So what we are really doing in this filter is, since this is a filter, this would be the entry point. Before it actually hits any of your controller classes, it would come to the filter first. You're just maintaining a count here on how many requests you're processing, and then for each and every request you increment it. After the request is completed, you decrement the count. That's it. And then if it goes beyond the max requests, you fail them, right? But there's one caveat here. In a regular non-production environment, this is probably okay, but imagine this from a, like this service is deployed into production, right? And now maybe your EC2 service is behind a load balancer, and then when it is behind a load balancer, it's not just the regular requests coming into the service, but there would also be the health check requests coming in, right, from the load balancer to your EC2 or ECS or whatever, like depending on where your service is deployed. So when you reject these requests here, like blindly, like, so here you're not checking like to which endpoint did this request come to, you're blindly rejecting each and every request, right? If you do this, what would happen is your health checks would start to fail as well, because when a health check request comes in, it sees that it hit the max request threshold, so it would immediately reject the health check with a 503. So once this happens, what would happen is that your load balancer will think that your EC2 instance is not healthy, and it would start taking them out of the pool, or your ECS tasks, or maybe your EKS, whatever it is, right? So this is really dangerous. Like your service is already under stress because your worker threads have gone up. On top of it, if your health check starts to fail, that will make it even worse, because then your EC2 instance will start falling out of your pool, basically out of the load balancer, and then it has to spin new ones again, and the new ones will be under heavy load because fewer instances are sharing the load now. So in order to avoid this, right, there is another way of setting up the load shedding filter. So what we'll do is we'll remove this component annotation, and let's go to another class called LoadShedding config, right? In here, what you're doing is basically you're still instantiating a bean here and then putting it into the context. So it is still the LoadShedding filter class here that you're trying to register, but the difference is you're adding your URL patterns here, saying you would only load shed your requests if the URL matches this one, like for example for our hello controller here, or if there are few more controllers, you can this can be a comma separated list, I believe. So you can just say some test/star, right, so on and so forth. Once you add this URL patterns, right, basically you would add every URL pattern that you want to reject, except for maybe health checks, right? So that is why when you are setting up load shedding, one important thing to remember is if your Tomcat max threads is 200, then you would want to set your max request to probably 180, right? Like leave the rest of the 20 threads for the health check request to come in. Like after it hit max request, right, a health check request would come in, but that would not match this URL, right? So that means it would not throw back a 503 for a health check request. It would let it go through and then perform the health check. So this is a really important point to remember. So leave some threads. If you have a max threads of 200, then set your load shedding threshold to some lower number, leaving some few worker threads for the health checks to go through. And again, this configuration is important, right? Because only with this you can add these URL patterns here. This is again the same thing with just the flexibility of adding your URL patterns. That's all. So I hope this is helpful to you. And one last point, right? I think it is really important, like when you set up your service, like so you have to work on the metrics, like metrics for monitoring your CPU utilization, your memory utilization, Tomcat worker threads as well. It is extremely important, because you have to know, because when your worker threads are busy, it won't really spike up. It might not spike up your CPU utilization. So on the surface, your CPU utilization would look normal, your memory would look normal, but the service is choking, right? You don't know what's really happening. So one possibility is that maybe all your worker threads are busy, and that is why you might be getting all these issues on your services which are dependent on your service. They are getting slowed down, right? So it is important to have some visibility, like some sort of metrics, maybe Datadog or Prometheus, or some metrics which would look into these properties or these metrics. You need some visibility, and depending on these metrics, you should have your auto scaling setup as well. Like depending on the number of connections coming in, like if you see a rise in your influx of connections, maybe you can auto scale on that, or maybe auto scale based on your CPU utilization, or maybe auto scale based on your worker threads. Like so once you have these protections in place, one, you can auto scale, and in a worst case scenario you can do load shedding as well. So in this way you're really protecting your own service as well as the other dependent services as well. So I hope this video is helpful to you. Let me know, share your feedback in the comment section, and if you like my video, please do share and subscribe. Thank you very much.